The 2019 exam was the first one to follow this new kind of advertised 4-question format for the free response questions. So it's a great one to look at in preparation for 2020. Specifically, if you look at the College Board's course description, it's on page 189. It's a pretty exhaustive document. But this is where we saw for the first time last year this 4-question description where they came out and told us, question 3 would handle an array or an array list or both, and we'd see a 2-dimensional array in question 4. We'd have to write an entire class in question 2. Kids never had this before, and so when you look at the older tests, they don't follow this format. You'll see these elements typically from year to year, but it was never advertised like which question numbers would adhere to which concepts. Take this to 2020 with the modifications to the exam. What they've now told us is that your question 1 in 2020 will mimic what was advertised to have been question 3, so the array/array list. And your question 2 in 2020 will now follow what was advertised to be question 1, which is this kind of mysterious phrase here, this methods and control structures, which if you've been watching my videos on the older AP exam questions, I've used that phrase a lot. Pretty much, when we see us calling helper methods, using instance fields, creating objects from a user-defined class, all of those types of things could fit in here. It's this big idea of object-oriented programming, the OOP. So again, your question 2 in 2020 will come from something similar to what question 1 was last year. All right, which brings us to 2019 test number 1. The kids had to do something called an APCalendar. Now, this is just something they made up. It's a user-defined class. It's got a whole host of methods in it. What's really interesting here is that there's 5 methods, and 3 of them are already done. So it says implementation not shown. And that means that this method's already been written by somebody and it does what it says it's going to do. So your main job here is to figure out, okay, what does this method do and how can I use it? And you better count on using it, okay? So as you've heard me say before, do not attempt to write code of this on your own. So part A of this question was pretty easy. I mean, they gave the kids 2 years and they said how many leap years were there from year X to year Y or whatever. And, I think probably the biggest difficulty that students would have run into here is trying to bring in their own knowledge and thinking, oh, I know what a leap year is. It's divisible by 4. Turns out, you can look this up on the internet if you don't believe me, that's not 100% true. For example, the year 1900 was not a leap year, so centuries are not leap years. However, you might be saying, well, wait, 2000 was. Yeah, there's an exception. So if it's a century, but it's also a millennium, then it is a leap year. And then there's some other really weird rules involving this. So, the Gregorian calendar turns out is not perfect. And in terms of like the solar calendar, and they have to do some weird corrections and whatnot. So you can read more about that on your own. But the bottom line is this. Kids that took this test last year, when they wrote their answer to part A, if they did any of their own math, like a modulus 4 or something, or if they tried to write a loop to count by 4s, then their answers are going to be marked wrong. So it doesn't matter what you think in that sense. Don't waste even if you know the perfect mathematical formulas for calculating leap years because you're a calendar junkie. Doesn't matter. Don't write the code. Just don't write that code on your own. Just trust the code that exists for you, and they gave you a method that will tell you true or false if a year is a leap year. So we have to trust their method. And then there's no mention in here of like negative or BC years. So just completely ignore that stuff. The precondition here states that these years are going to be non-negative. Okay. And we also want to note that this is important. It says inclusive. So whatever type of loop you write, make sure you allow year 1 and year 2 to both have a chance to be counted as leap years. And again, if you read my little note on part A here, if you're using modulus 4, your answer is wrong. Okay, so just keep that in mind. Or if you're trying to make your loop count by 4s. All right, so just keeping those things in mind. This is a basic counter method. all right? And we're looking to return the counter, okay? In the middle, we're gonna write a loop, and not all loops start at 0. This loop most conveniently would start at year 1, okay? And we would allow this loop to reach and include year 2, and very important that that's inclusive on both ends. And then all I need to do inside this loop is simply ask, if I take that value I, and by the way, you could easily write a while loop to just run from year 1 to year 2 and increment year 1 or whatever. But using I'm now going to call that method. Okay? So the method that I want to call is the helper method, is leap year. And to use that method, I have to give it an int, and then just one, and then it gives me back a Boolean. So is leap year, okay, hand it the value I, that comes back as either true or false. If you wanted to, you could say equals equals true. It's just a little bit redundant, and we'll simply count it if it is a leap year. All right, but if you're not using that method, your answer is wrong. It does not matter what type of mathematical formulas you write, what kind of loop you structure to count by 4s. It's wrong. Okay, you can read the rubric on your own, look it up on the internet, whatever, or you can just trust me. All right. Okay, so now we move on to part B. And in part B, we have to do this thing. It's some people use this. It's kind of like a little parlor trick, but you tell me a month, day, year. I'll give you like a day of the week, and day of the week is coded. 0 is Sunday, 1's Monday, and so on. And again, they give me some helper methods to write part B. So for example, they give me a helper method called first day of year. And so this comes back and tells me, like, what about January 1st in 1950? Was it on a Monday? Was it on a Wednesday? I don't know. But this method would tell me the answer to that question. Or, so if you give me a year, say the year 2000, this method could tell me if the first day of the year in 2000 was a Saturday or a Friday. It would come back to me as a number, either 0, 1, 2, 3, 4, 5, or 6. It never comes back outside of that range. All right. So you give it a year, it gives you the first day. And then there's another method called day of year, which if you give this a date, so for example, September 10th, 2012, it's going to come back, it's going to say N, where month, day, and year specify the nth day of the year. So for the first day of the year, January 1st, the value 1 is returned. This method accounts for whether the year is a leap year. So it takes all that stuff into account, okay? And I know we could figure this out on our own, because we know that January has 31 days. We know that February has 28, and we could put the leap year in. But you don't do that, okay? You don't bring in your own calendar knowledge here, right? You simply trust their method. There's an extra little trick here, and you got to really watch for things like this. So one of these numbering systems starts at 0, okay? So Sunday has been labeled 0, okay? Day 0. However, this day of year method doesn't work that way. It treats January 1st as day 1, not as day 0. So if you look at their example really carefully here that they're walking you through, which handles, like January 10th, 2019, so they point out to you that like 2019 began on a Tuesday, so that method would return 2. January 10th is the 10th day of the year. So it's then saying, well, okay, so what about January 10th? Is that a Sunday? Is that a Monday? What is it? So if I took the 2 from the fact that 2019 begins on a Tuesday, and the fact that my second method gives me 10, 2 plus 10, now I can't have 12 because it has to come back as coded 0 to 6. If you take 7 away from 12, you get 5, which seems to imply Friday. But it's not. It's actually a Thursday, and like they said, it should return 4. That's because of that little mismatch there, how the 10th day really means that you're 9 days after the first day. So in other words, like it's kind of like you're adding here a 9 in a sense, like 2 plus the quantity of 10 minus 1, or or if you want to list it out the way I had it there first, it doesn't really matter there. But okay, the bottom line is one of these numbering systems starts at 0 and the other one doesn't. So we're going to have to put that little corrected -1. So if you look at this math formula I have here, I mean, this is it. We just have to write code to do that. So we have to call the first day of year with the year that we're handed. In this case, that would have given me the 2. Then I have to call day of year with the month, day, and year that I'm handed. That would have given me the 10. Then I have to take away 1 because of the mismatch in the numbering systems. And then I have to take a modulus by 7. And that's it. So this, you could actually write just like a one-line answer here. There's no loop component to it or anything. You just got to know how to use these helper methods they provided you. So really, if I wanted to, I could just write like a one-line answer. So for example, first day of year, okay, that's going to do its magic, and I'm going to just give it the year. I'm going to add to that then the next method that they gave me, which was called day of year. All right, so day of year. Now that method wants a month followed by a day followed by a year handed to it. I'm going to subtract 1 from that quantity, and then I'm going to put that whole thing in parentheses, okay, because modulus has higher precedence here, so I have to be careful. I have to make sure the addition and subtraction is completed. And then my modulus 7 simply puts this into that 0 to 6 range. You know, if you don't know how to use modulus effectively, you might end up writing some really weird loop or trying to write a whole bunch of if statements here or something and really end up confusing yourself. So it's good to know how modulus works. And if we look at some of these examples here, so notice it says like I should get 3, 5, 6, 0. Because I was kind of jumping around. First, I did their 2 examples that were in the directions, and well, actually, I kind of modified it a little. And then I started jumping around in 2020, and you could go check these out. March 6th was on a Friday, okay, and then March 7th was on a Saturday of this year, 2020. You can go look that up if you don't believe me. And if we look at like the leap years, this kind of here 5, 25, 0. Those are correct. It's weird. Like I said, 2000 was a leap year, but 1900 wasn't. That's why there's 0 leap years from 1900 to 1903. Again, if you don't believe me on these things, you can search it on the internet real easily. But yeah, everything looks like it's working. And if you look at this, I wrote very little code here. Okay, so even though we had a few pages of directions, we had to read it, we had to grasp all of those helper methods. Look, I wrote 5 lines of code in part A, and I wrote 1 line of code in part B. So writing more is not better, okay? That's a very important lesson to remember with your AP Comp Sci. Could I have written more lines? Sure. I could have made like a line of code out of this method call. I could have made a line of code out of this method call. But really, you shouldn't be using more than 3 lines of code in part B. All right, and again, this is a very good problem to review, because we're being told this year that your question 2 on your 2-question exam is going to come from what they have labeled as FRQ1. So 2019 was the first year with this new numbering system. So this is the only real FRQ1 example that we have to look at. Now there's other problems that were similar through the years, but this was the only one that advertised that way. All right.